All right, welcome back to page 2. Before we begin, if you remember this worksheet, if you have it, this will help you out for what we're doing, because on the back are some theorems and postulates here that you can use for our circles. So we have...
hand.
That's right, you want to see your hands? Put your hand under. There's Kate's hand. Say hi, Kate. Say hi.
Hi.
Okay, gotta let Daddy do work, okay? High five.
Can I watch you?
Sure. Okay, so the first one is if we have the situation like this, just parallel chords, create congruent arcs. We're going to use this one today. Inscribed angles with the same intercepted arc or congruent arcs are congruent. Okay, congruent chords and congruent arcs. Equidistant from the center. We have the hat rule. We can't actually write the hat rule. It's just two tangent lines from the same point outside the circle are equal. Inscribed angle in a semicircle is 90 degrees. Okay. Opposite angles of a quadrilateral inscribed in a circle, I do 180. And then our tangent is perpendicular to the radius at the point of tangency. So that's the basic gist of it. We can kind of put these in our own words as we work along. But that's what we're using today for our purposes. Okay, so for number 5, I edited down here, got the statements already, just filling in from here. And we're trying to prove that these two angles are equal. So nothing to mark congruent. The only thing I do see is a keyword here. That's another thing I'm going to look for is keyword, which is midpoint. So remember the midpoint, what it does is cuts a segment, or in this case, an arc, into two congruent pieces. So we know if C is the midpoint of arc AB, right, and technically this should say arc ACB because it's a major arc more than 180 degrees. So we'll rewrite that here, okay? So we're going to say that arc AC is congruent to arc CB, and it's the same reason we stated before. This is just definition of midpoint. If you want to put down that a midpoint will divide the arc into two congruent pieces, you're more than welcome to. So now we can mark that these two are congruent. Now remember the rule. For this angle formed by a tangent chord, right? Tangent chord. This angle is equal to half the arc. All right? So what we know is that both angle CBD and ABC are equal to half of those arcs. Okay? And that's the definition. I mean, that's just by definition of how they're formed. Okay? So because these are half the arcs, and the arcs are equal, the angles have to be equal. So we can now say that angle ABC is congruent to angle CBD, and we're just going to fill in the reason. We can put this in our own words if we want. We're just going to say both angles are equal to 1/2 measure of the intercepted arc and both arcs are congruent. And therefore the angles are congruent. That's it. We're putting in our own words. If these were both inscribed angles, right? So there was another angle using this same point, then we would just say, that inscribed angles with the same arc are equal. But this isn't necessarily considered an inscribed angle. It's the same property, though. So we're using the same thing. Number 6, in the accompanying diagram, we know that angle BR, or arc BR is 70. We can label that over here. And arc YD is 70. Okay? And that BOD is a diameter of circle O. Write an explanation of proof to show the triangles are congruent. So the two triangles are RBD here and then BYD. So there's a few things we need to talk about, right? Do you guys see anything going on? Like these triangles are overlapping. So we should be able to see that this side is reflexive in both. Okay, so BD, line BD is congruent to line BD. Now here's what I want you to do. see if you can think about the properties of a circle and see if you can tell me if there's anything else that you think is congruent here. So pause for a minute, okay? Check it. What else do you think might be the same? No, really, pause it and try it. Serious. Okay, this is going to take a level of participation on your part here too, as we go along with these flipped classrooms. Just try for a little bit, and then we'll go over it, especially during the review part. But okay, so what did you notice? Hopefully, you noticed that these two arcs are equal, right? So we can say that arc BR is congruent to arc YD. Okay, so arcs with the same measure are congruent. You can also put definition. Congruence would work there too. All right, and if these two arcs are equal, then the inscribed angles being formed here also have to be the same. It's almost ready. It's almost ready. Okay, so angle YBD, go see in my room. Go in my room. Go see mom. Is going to be congruent to angle RDB. And these are the two inscribed angles. Remember what we said before, right? Bringing it back. Inscribed angles, the same intersect arc, or that intersect the same arc, are congruent. So inscribed angles with, now this is not the same. So we're going to say congruent intercepted. If you left this off, that's okay. Arcs are congruent. And that's it. Okay? The other thing we're going to need is the fact that these two inscribed angles, oh, we can add to that. Look at this. These two inscribed angles are also 90 degrees, right? But they also form the same arc. So we can actually add that onto the last reason. So we can put a comma, and we can put angle BRD is congruent to angle, and here we got BRD, so DYB. Now we could say they're 90 degrees and then do substitution, but we can also fit this right into this part. And so now we have a side and two angles, and if you have trouble seeing it, try to redraw that triangle for yourself, right? Here's BRD, and we got this angle, right? This side and that angle. So here you can tell we have angle, angle, side. So now I can say triangle RBD is congruent to triangle YBD. And this reason is just going to be, like I said, angle, angle, side. Okay? And that's essentially just circle proofs. So we're kind of using what we know about circles with inscribed angles being congruent to share the same arc. Sometimes there's going to be radii that are the same. You'll see that tomorrow or Monday in the next lesson. Arcs that are equal if they have the same measure. That's the kind of thing that we're going to be putting down. All right? Thanks for following along, and I'll see you guys on Monday. Have a great weekend, guys.